So we've spent the past few days talking about congruent triangles, and we've been proving triangles are congruent over the past few days. So let's talk a little more about congruent. Right here, I have a race car. In fact, not only do I have one race car, I have two race cars. They're the same, except for the paint job, they're pretty much the exact same car. And that's pretty obvious. So we could say these two cars are congruent. They have all the same measurements. Now, since they're congruent, then it means that the wheels are going to be the same on both cars. They have the same size wheels. They have the same size hoods. The painted numbers are the same. Everything about these race cars is exactly the same. So we can say that all of their parts are congruent. Let's take a closer look at that. So as we're looking at the size of the numbers are going to be the same size. The roof flaps are the same size. The windshields are the same size. All of the parts of these two congruent cars are also congruent. We can apply that same strategy to triangles. And that brings us to our next bit of the lesson, lesson 3.3, CPCTC. Now that's a big mouthful of something to say, but what it means is that whenever we've got two triangles that are congruent, all of their parts will also be congruent. So after we know the triangles are congruent, then each of the corresponding parts of the triangles are congruent. That's the actual theorem. We abbreviate that as CPCTC, and we can abbreviate that way in proofs too, so you don't have to write this out every single time. But what it stands for is the corresponding part, remember corresponding means matching, parts of congruent triangles are congruent. That's what it stands for. Okay, so I want you to know corresponding parts of congruent triangles are congruent. Don't just know CPCTC. Now, the key to doing this, to use this in a proof, you must first show the triangles are congruent. Okay, if you don't know the triangles are congruent, then we don't know their parts are congruent. So a quick example of how this gets used in a basic proof that you might see. So here we've got a proof. I'm given that B is the midpoint of AC. AD is congruent to CD. So we start our proof just like everything else. B is midpoint of AC. AD is congruent to CD. And they've marked a lot of things in this already, but I'm going to mark them again so that I can mark them in colors. So AD and AC and DC are congruent. Again, we go with our given. If it's a midpoint, then I know a midpoint creates two congruent segments, which means that AB and BC have to be congruent. So far, nothing different than what we've been doing over the past couple of days. I'll mark that in my picture, even though they've already got it marked. And they kind of gave away my next piece too, okay? We know that DB is congruent to DB by the reflexive property. So far I can see from this, I've got one set of sides there, another set of sides there, another set of sides there. So we can see from what we've been doing all week by side, 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 the triangles are congruent. Triangle A, B, D. Now I have to remember to name my triangle properly. A matches C, so triangle C. B and B match up, and D matches up. Now this is not what we're trying to prove. We're trying to prove a couple angles are congruent. But these angles, DAB and DCB, are parts of the triangles. In fact, they're the matching parts. We just said A matches C. So now I can say, since the triangles are congruent, then I can say that the corresponding parts of the congruent triangles are congruent. And that gives me that angle DAB is congruent to angle DCB. So you know you're going to be using this when you're faced with triangle proofs, but you're not trying to prove the triangles are congruent. You're trying to prove parts of the triangles are congruent. So you do the same thing we've been doing. go through the triangle proof, and then it's just one more little step. Now we can continue on and prove other things too, and we'll see some of that in class. But that's the basic idea of CPCTC. Whenever I have a congruent figure, then any parts of these two congruent figures are going to be the same. So congruent figures, all their parts are congruent. Okay, we'll practice more on this in class.